So let's proceed with couple-up operations. Couple-up operations. So this is also a protocol, or it's a standard used, but now this one here, it is used in wireless LAN controller to control the AP, multiple APs on a network. So there is a video here. It will cover the following. The couple-up, it stands for control and provisioning of wireless access points, access point functions. Then it will cover sprint media access control architecture, then the datagram transmission layer types, and then encryption, and then we have the flex connect AP. So couple-up, it's just a standard protocol that enables wireless LAN controller to manage multiple APs and wireless LAN, based on lightweight access point protocol, but it adds additional security, security with datagram transport layer security, encapsulates and then forwards wireless LAN client traffic between AP and then the wireless LAN controller over tunnel using UDP port. It's 5246, and then 247 a continuation. So it operates over both IPv4 and IPv6. So with IPv4, it uses IP protocol 17. IPv6, it uses IP protocol 136. So as you can see, this is a controller, and then the protocol called the couple-up, it's the one that is used to, it's a tunnel to control the APC. So it's this protocol that is used to create the tunnel to control all these access points. So the couple-up splits MAC address concept. Couple-up sprint MAC address concept does all the functions normally performed by individual AP and distributes them. So between two functional components, it distributes them between two functional components. So we have AP MAC and then the wireless LAN controller. AP MAC function means that the APs, they have to manage. They have to manage their functions by themselves, and then when it comes to the controller, it means that it's a wireless LAN controller that will manage the functions. That every time an access point sends, then the controller on the other side, it's the one to manage, or it's the one to handle that. So we have a table here differentiates the two, that AP MAC function beacons and probes the response. Now it's the AP to keep on advertising its information. And then when it comes to wireless LAN, so wireless LAN controller, it means that anytime it's the controller to actually connect the clients, not the AP. The packets acknowledgements and then retransmission, it's done on AP, but the association and reassociation of roaming clients, it's done by wireless LAN controller. Frames queuing and then packet prioritization done by AP, but frame translation to other protocols, it has the local, the wireless LAN controller. So it's the controller when it comes to wireless LAN controller MAC function is the one that manages, and then when it comes to AP, it's the one that on standalone. But all these other in controller, all these other AP, they will be forced to forward to the controller for management. When it comes to datagram transport layer security, provide security between AP and then the controller. It is enabled by default to secure the CAPAP controller channel and encrypts all management and control traffic between the two, the controller and the AP. Data encryption is disabled by default and requires datagram transport layer security license to be installed. So for encryption, you need license to be installed on the controller before it can be enabled on AP. So it's not for free of charge. So we have what you call Flex Connect AP. It enables the configuration and control of AP over a one link. So there are two modes where we have connected mode that the controller is reachable. The Flex Connect AP has CAPAP connectivity with the controller through CAPAP tunnel. So the controller performs all CAPAP function. Then when it comes to standalone, the controller is unreachable. So Flex Connect AP has lost CAPAP connectivity with the controller. So Flex Connect AP can assume some of the control. Flex AP can assume some of the controller functions such as switching client data traffic locally and then performing client authentication locally. So we have two modes where we have connected mode that this AP, as you can see, it has to reach the controller for all the functionalities. But when it comes to standalone, it means that the Flex Connect cannot reach the controller. So it has to assume the functionality of the controller, like such as switching client data traffic locally and then performing the authentication locally. Channel management. So if the demand for specific wireless channel is too high, then the channel may become oversaturated, degrading the quality of the communication. Most of the time, if there are too many users on the access point, of course the performance is worse. So the channel saturation can be mitigated using techniques that use the channel more efficiently. We have direct sequence spread spectrum, we have frequency hopping spread spectrum, then we have orthogonal frequency division multiplexing. So the descriptions are there, you can actually try to read. So with this modulation technique designed to spread signals over a large frequency bandwidth used by B device to avoid the interference from other devices using the same this. Then when it comes to frequency hopping, spread spectrum transmits radio signals by rapidly switching carrier signal among many frequency channels. Send and receiver must synchronize to know which channel to jump to, used by signal standard. Okay, so please read through this, the description of that. Okay, the channel selection, channel selection. So the 2.4 gigahertz bandwidth is subdivided into multiple channel each allocated 22 megahertz bandwidth and separated from the next channel by 5 by 5 megahertz. So when you look at this, that each channel, now the non-overlapping channels, they're this. We have a one here separated by 5. So you will count here that we have 1, 2, 3, 4, 5 to go to the next one. So most of the time, as you can see, we have one here, then the non-overlapping, we have 6, and then we have 11 separated by 5 in between here. That if you add the 5 here, and then a 5 here, you get 2. So these the overlapping channels, those ones are not used. So the best practice for standard BGN wireless requires multiple AP is to use non-overlapping channel, which is 1, 6, and then 11, as you can see here. So for each channel here, it has 22 megahertz from here, 22. So between the channel here, we have 5 is 5, then the next 5, we have 5 here. Like that, up to this, the 22 giga hertz. Then when it comes to 5 gigahertz standard, whereby we have ANC. There are 24 channels. 24 channels. Each channel is separated from the next channel by 20. From the next channel by 20. Each channel. So when you look at this, where is it? So the non-overlapping channel here, we have 36. And now you're going to tell that it's a 36. So this is our channel here. As you can see, it's from this point to this. And then you start the next one. This is the next one that is not overlapping. 48. And then we have even this other one. So it is 36 and then 48 and then this 60. That is under 5 gigahertz. 5 gigahertz. So the plan a wireless deployment, the number of users supported by wireless LAN depends on the following: the geographical layout of the facility, then the number of bodies and devices that can fit in space, then the data rate user expects, and then the use of non-overlapping channel. Non-overlapping channel. So when planning the location for AP, the approximate coverage area is important. So you have to make sure that you use when you look around here, which one, because these are channels that if you have an access point here, it will cover all this space. If you have this, it will cover this. If you have this, it will cover this. So which one is going to actually cover the areas that you feel the geographical area? Which one? Because now if you have one here, for example, this, it will cover only this space. This, meaning that people at the exit here, they will not access this, they will not access. They will not access even this. So you have to make sure that you have this. So with this one here, with this, as you can see, you'll have to have this, and then you find that the others that will, because these are the access control. These are not frequencies. These are the access. They are access, the wireless, plan for wireless. So I don't want you to confuse this with the frequencies. Do not confuse. These ones here are the access points. That if I have this, it will help me to cover all this, and all this stuff. So wireless LANs, we have a video here that will cover interception of data, then wireless intruders, denial of service, and then rogue AP. Wireless is open to anyone within a range of AP and then appropriate credential to associate it. So attacks can be generated by outsider, disgruntled employees, and even unintentionally by employees. So wireless networks are specifically susceptible to several threats, including the following: interception of data. And there are those smart people who are always on the network. Every time you send this, you're chatting with your people, relatives. Someone is busy with a tool monitoring what you're doing. Wireless intruders, the unwanted people on the network. Denial of services. You're trying to access the wireless network, but you're denied. You denied. Then rogue APs, creating. You have CCNA as an access point, and then someone rogues this and assimilates the exact one. And for you assume that you're connected to the real one, but you're connected to something that is different. That whatever that passes through that rogue AP, someone is easy for that person to intercept and check exactly what you're sending. If you're doing the sensitive transaction, they can be edited. Your password, they can be tracked. That's a reason why I hate doing sensitive matters on wireless network. Do not use those mobile apps and blah blah on wireless network. Just buy data, 1,000 or even 500. You can actually buy data like 30 MBs, 40 MBs, and you do the sensitive transactions. Yeah, so the rogue access points I've talked about, the man in middle. So man in middle, they can actually be assimilated in so many ways. You can actually connect on the rogue AP, and then you end up tapping in the man, or the man in the middle tapping into your connection. Secure wireless. How to secure wireless? This is a video SSID clocking, MAC address filtering, authentication, encryption system, and then open authentication and shared keys, all that. So to address the threat of keeping wireless intruders out and protecting data, two early security features were used and are still available on most routers and AP. We have SSID clocking. AP and some wireless routers allow SSID beacon frame to be disabled. So you can actually disable the SSID so that no one will ever tell that there is this network on the network. Then MAC address filtering. You can filter that, I want this MAC address. If in an office you're like 3 or 4, allow only those 4 MAC addresses to access your access point. The rest out. The rest out. The original authentication modes, best ways to secure wireless network is to use authentication and encryption system. 2 types of authentication were introduced with the original frame standard, which is open system authentication, no password required, typically used to provide free internet access in public areas like cafes, airport, and hostel. And you need to avoid all that, the free Wi-Fi and blah blah. Never accept. Never accept. There will always be smart people there to tap onto your transactions or into your the network moves. Then we have shared key authentication provide mechanism H, where we have web, we have uh, the wireless protection access, wireless equivalent uh, pro- uh, protection. So to authenticate and then encrypt data, encrypt data. Version. So this is the web, it's wireless equivalence privacy. Then this one here, it is Wi-Fi protected access version 2 and then 3, that requires you both parties to provide. So the client will provide the locate the name, the SSID, and then provide the password, and then the AP will actually authenticate that the password provided, it is the password on that on the device, or search on under AP. So the authentication modes, they are here, where we have wired equivalence privacy, wired equivalence privacy, and then Wi-Fi protected access version 2 and version 3. So the difference is here in the description. With web, originally this, it comes with the original standard of wireless specification designed to secure data using that cipher 4 encryption method with static key. So the static key, it's just there, it won't change. So it is easy for these threats to actually decrypt it. Web is no longer recommended and should never be used. So we have Wi-Fi Alliance standard that uses web but secures data with the much stronger with temporal key integral protocol, KIP, temporal key or temporary key integrity protocol encryption algorithm. Changes the key for each package. So every package that is exchanged, then the key is changed, making it much more difficult. Much more difficult. So with this one here, it's the web, but it uses temporal key integrity protocol. Then we have version 2, it uses advanced encryption standard. For encryption, is currently considered the strongest encryption. Then version 3 is the next generation of Wi-Fi security. All Wi-Fi protected access version 3 enable device use at least security method. Disallow outdated legacy protocols and requires the use of protected management frame. So authenticating home user, as you can see, we have personal and enterprise. So for personal, is when the actually the options are here under the AP, that those settings, they do reside on that very device. But when it comes to enterprise, then it means that you have a server whereby all the authentication keys, details, the password, they have to reside on the server. The server. That's the difference. So with personal, intended for home and small office, that the device there you're using, that is where the passwords are going to be created. But when it comes to enterprise, they can be created on a server somewhere. like in the other scenario of wireless LAN controller. That is where we can use the enterprise. But on standalone, that is where we have to use the personal. And then the technologies that we talked about, the temporal key integrity protocols, they are here. The integrity, the encryption. So you can select which one is it, WPA, is it web, and then after that you go for encryption. The encryptions, they are here, as you can see, advanced encryption, encryption standard, it's there. We have temporal key integrity protocol, it's also here. Then when it comes to enterprise, we have Radius, the Radius server, where you have to have the IP address of the server and then the ports to reach those servers. And then the shared. Is it going to be a shared key? Because the shared, it has to be exchanged between the client and then the server. So we have this WPA version 3, personal, then the enterprise, then the open, and then so that is the end of the session.